So yeah, do not rewrite that 1 and the 5 there. That's going to be wrong, okay? But then once you simplify it back down in terms of x, you can evaluate from 1 to 5. Okay. Yeah, at this point now, you can just plug in. And I'll get you, Brandon, 1 second here. Let me just finish writing. Okay, so minus, and then 1/5 times 10 times 1 minus 1 to the 1/2. Okay, question? Say again? So, no, because it's a definite integral, remember the c's disappear in a definite integral because it'll be the upper limit plus c minus the lower limit plus c, so the c's will cancel because of the c and the upper limit minus the c and the lower limit will cancel. Okay, so the c's cancel in a definite integral. So we can stop here, or we can go ahead and just simplify it because it actually does simplify it rather easily. 10 times 5 is 50, minus 1 is 49, square root of 49 is 7, so it's 7/5. And then 10 times 1 is 10, minus 1 is 9, 9 to the 1/2 is 3, minus 3/5. So the final answer after all that work is 4/5. Okay? How nice. Because math, that's right. Now, that's one way to do these. All right, that's one way to do these. However, there is an alternative way to do this. There is a way to get numbers for these limits of integration. We can't use the 1 and 5 because those were x limits of integration. So we somehow need to come up with u limits of integration here. Well, what do we have that tells us the relationship between u and x?
We have let u equals 10x minus 1.
U equals 10x minus 1.
So you just plug in the numbers there.
So exactly right. If 1 is an x limit, I can translate that to be in terms of u by plugging the 1 in for the x right here. So it'd be 10 times 1, 10 minus 1, 9. So my lower limit here, I could alternatively say, is 1/10 the integral from 9 to, and I'll plug 5 in for x. 5 times 10 is 50, minus 1 is 49. So from 9 to 49, okay, of that u to the negative 1/2 du. Okay, so there's the alternative. So the alternative here is you can adjust your limits of integration to be in terms of u. And now when I integrate, I still get, I'm still going to end up with 1/5 u to the 1/2 plus c. I'm going to evaluate from 9 to 49 at this point.
So at that point you would not plug in 10x minus 1.
Correct, because now I'm still in terms of u. I'm going to evaluate using the u limits of integration. So I've integrated, done that. I'm going to plug in my limits. So it's going to be 1/5 49 to the 1/2 minus 1/5 9 to the 1/2. And what does it end up being? 7/5 minus 3/5, which is 4/5. Okay? You can choose whichever way you wish to go. You should be familiar with both ways, though. Okay? Because it's very typical. Here's a very common AP kind of question I've seen. It's mostly multiple choice kind of question. Typically, in an AP kind of multiple choice question, you'll be given a function, you'll be given the u substitution, and then you'll be asked to pick among the multiple choice options which is the correct setup for that u substitution. Okay? So the idea is you'll be given this, you'll be given the u substitution, and then you will be asked to determine which among these choices is the correct setup, and it'll be something like this that you're looking for over here. So yeah, Brandon.
I know, this is for the sake of understanding, when we didn't put the limit of integration on the first of 1/10
Mm-hmm.
and that, but isn't that no longer become equivalent when you say 1/5 of 10x minus 1 plus the evaluate of 1/5?
I see what you're saying. There. That is true. That is correct.
Did they mark you off for that? They're no longer equivalent.
You're right. They aren't equivalent. I think typically you don't see these kind of u substitution problems. That's a good question. Maybe I shouldn't say equals here. I'll just do that. And then this equals really this down here.
Then what? Well, don't we have to show a relationship?
This is kind of like side work here, though, I would say, or something like that. Although I really can't say whether you would lose points there or not. I don't know.
Same with the c there. Do you just want to keep the c throughout all this? Or?
The c's, the c's okay because it's going to disappear eventually. So yeah, I think technically it should be there. But again, I don't know if it would be worth a point or not, potentially.
Well, so we wouldn't have to show the relationship between our original function and u sub, because obviously it isn't equivalent. so is there any way to show that relationship? Because there's obviously a relationship there, I mean, there can
Right, yeah, I think you just do it to the side and then you rewrite the equals there. But I'll say this, I feel like most of the time you see problems like this, it won't be a free response, I'll question, it'll be multiple choice, in which case your work is not meaningless, but it's like not going to be like scrutinized, you know what I mean? So I think majority of the time these use substitution problems are just,
multiple choice.
yeah, multiple choice, so, yeah. We'll see some examples of it and stuff like that, though, later when we get into review and all that. And you'll get an idea about what, you'll really want to make sure you have down. Okay, let's try another one here. Integral from 1 to 3. of y squared, or sorry, e to the 3 over y squared dy. Okay, so e is being raised to the 3 over y power, and it's all over y squared dy. Yeah, that's a y. Okay. So, can we integrate it as it's currently written? No. Can we manipulate this at all?
Yes.
Kind of.
I just did it.
It won't really be.
But not really, I don't think it'd be super, like, how did you manipulate? What did you do? Wrote a y to the negative 2?
And
Okay.
3y, and e to the 3y to the negative 1.
I gotcha. Okay, and you could do it that way. Yeah.
Well, in these kind of problems.
It's 3 over y, and then it's e to the 3 over y and over y squared. All right, so we probably have to use a u substitution here then. So what should we let u equal here?
Y then negative 2.
Y to negative 2? All right, let's try y to negative 2. Okay? Bless you. Wow, saying bless you and you're blowing your nose. That's weird. I'm sorry. Nate. Strange. Anyway, okay, du equals. What's the derivative here?
It would be y to the negative 3.
Negative 2y,
Negative 2y to the negative 3. Okay, yeah, you can see we're gonna have some problems here. We don't have a y to the negative 3 anywhere in the problem, so that's gonna be tricky for the substitution. So this is okay. This is okay. That's not the correct use substitution. So Tyler.
I think it is 3 over y.
Well, let's try 3 over y. Okay, which is really, remember, 3 over y is the same thing as 3y to the negative 1. Right? Du then would be what?
Negative 3, that's why.
Negative 3 y to the negative 2 dy.
Shouldn't it be negative 3
Question?
halves?
Would it be incorrect to like,
Derivative.
could I put 1/3 over with u and then take the derivative from there? And have 1/3
Yeah, you
du
could.
equals
Yeah.
dy?
Because we're doing the same thing here at the last step anyway,
Okay.
so yeah. So now if we look in here, do we have a y to the negative 2 in this problem?
Oh, yeah.
Yeah, there it is. Okay, it might not be so obvious, but we don't have that negative 3, so what should I do with this negative 3 here?
Shouldn't it be
Divide it over, just hang on, just hold on there, Ryan. All right, negative 1/3 du. All right, y to the negative 2 dy. Okay, which is really then negative 1/3 du 1 over y squared dy. And so we have that exact thing right here. There's 1 over y squared dy, so it subs in, and we get the negative 1/3 goes out front. Okay, and then that's going to be e to the u du. So that mess becomes just e to the u du.
Shouldn't it be negative?
Question? More pointy? Alright. Pointy. Pointy. That's a U! I just messed up!
Golly.
Wow. Why?
I
Alright,
don't know.
go ahead, Ryan.
Shouldn't it be negative 3 halves y to the negative 2?
What is the derivative of y to the negative 1? What do you do when you take the derivative? You bring the power out front and lower the power by 1. Okay? Derivative. You integrate it. You kind of like mix your integral and derivative stuff together. So yeah, be careful. That's we have to be really careful with here because we are both integrating and differentiating in the same problem, okay? So you have to really be on your toes there. That's why you really need to know those derivative integrals. Not that I'm saying you don't know them, but I mean you want to really be familiar with them in and out, okay? Be real comfortable with them. Okay, anyway, integral of e to the u. Actually, I'm going to adjust my limits of integration here too. I like to do that, okay, myself. So let's change our limits of integration here. So 1 becomes what? 1 in terms of y becomes what in terms of u? 3. 3 in terms of y becomes what in terms of u? 1. Yeah, okay, it's a little bit weird here. So we're integrating from 3 to 1, but that's the way it worked out.
Wait, I just missed that. So,
you're okay?
yeah.
Just plug it in. Plug the 1 in for the y. 3 divided by 1 is 3. Plug the 3 in for the y. 3 divided by 3 is 1. Okay? And now we evaluate. So negative 1/3 e to the 1 minus negative 1/3 e to the 3. All right, and we really can't simplify much more than that. You could like factor out a negative 1/3 e if you wanted to. So we could say something like negative 1/3 e, and then it'd be what, 1 minus e squared. If you wanted to do that, but you don't have to factor it. Either one's fine. Okay.
We're down, good to go.
Okay. One thing I want to point out too, folks. On the test, we had some situations where we were like subtracting e. Oh, I don't want to say too much. Never mind, because there are other people that still have to take the test, and that wouldn't be fair to give them the heads up that you guys didn't get. So I'll have to wait until they're all done. Never mind. Okay.
I'm sorry.
Well, yeah, you'll know.
All right, we're halfway done.
Okay, next one. Let's try another. 1/6 to 1/3 of 6t plus secant
I already messed up.
pi t tangent pi t dt.
Will there ever be a situation where it's easier to get your limits in terms of u versus just waiting till the end? Like, does it matter, or is it just preference?
I think it's preference, but like I said, you should be familiar with both ways because the AP test can force you to do the one where you convert it in terms of u. Okay. So,
I like this one. This is a good one.
how can we kind of start this out here? Okay, so we need to let u equal something here, Connor? What should u equal?
Either gonna be, I think it's secant.
I think it's secant? Like secant pi t? Alright, let me point something out here first. So we'll hold off on the secant pi t thing right now. Addition,
You can break it up.
we can break it up. Okay, when you have addition and an integral, just like when you have addition with a derivative, right? If I want to take the derivative of this thing, I would take the derivative of this plus the derivative of this. If I want to integrate it, I can take the integral of this plus the integral of that. So let's break this up. That's what we should really do here to start out. Okay, so 1/6 to 1/3 6t dt plus 1/6 to 1/3 secant pi t tangent pi t dt. Okay.
Do you want to use two different u's for?
We could, if we needed to. Do we need a u substitution for the first one, though?
No.
Yeah, no, we can integrate that right away. So I'm going to go ahead and just do that. And so we get, 3t squared, and we're going to evaluate that from 1 to 6. And plus, now to integrate this, we need to use a u substitution. Okay. And so, Connor, you said let u equal secant pi t? Okay. Connor, what's the du going to be then? Secant what? Secant pi t, tangent pi t,
dt.
pi dt. Multiplied by the derivative of what's inside. Right? Chain rule there, don't forget that. So again, the derivative of secant pi t is secant pi t tangent pi t times the derivative of what's inside, pi, and then dt. Okay. Do you see the issue here? The secant pi t will be substituted with u, but then we're left with tangent pi t dt, which is right here, but we still have another secant pi t, which we don't have over here.
Wait, couldn't you...
Hang on a second, let me finish with Connor. I'll get to you, Ryan. 1 second.
Wait, why can't we? Because it has everything.
Secant pi t, that's going to become u. So we're left with tangent pi t dt, right? Our du, though, to substitute in du, that's equal to secant pi t, tangent pi t, pi dt. Well, there's the tangent pi t, there's the dt, the pi is no big deal, we can move that over. But we don't have another secant pi t here, we only have the one. Do you see what I'm saying? So we can't do that substitution. Emily, you have a question? Okay, 1 second, let me get Ryan. Is that what you're going to say too, or you have a question?
No, I was going to say, couldn't you divide out the secant in front of the
T outside of the integral.
Yeah, okay, so we could divide the secant pi t over to here too, but then when we do our substitution, there's going to be a du in there and a secant pi t in there. We'll have du's and t's in there so you're saying divide this over to here, right?
Yeah, and then you can put it outside your integral. And
No, secant pi t has a variable, you can't pull it outside the integral. Variable.
Okay.
Only coefficients like pi.
Yeah.
So good thinking, but I want to clarify that. So yeah, so it's not, so long story short, Connor, you chose poorly, but that's okay. That's wrong, but that's okay. That's going to happen. It's important that we're able to diagnose that we're wrong there, and now you can see that. Emma, what do you think you should be? Yes, let u equal just pi t. Yeah.
So the first one was wrong because it was missing a pi?
The first one was wrong because our du, we did not have what we needed to be able to substitute in that du. We had this extra secant pi t. Well, the pi doesn't matter because it's a coefficient. I could divide that over and we can just pull the coefficient out front. Right? It's like a 3 or a 2. I can divide that over and it subs in no problem. It's the fact that I have this secant pi t that's not, I can't account for that over here. It's already, this secant pi t is already u. There's no other secant pi t to allow me to sub in. Yeah. I don't think they will. I've never seen a multiple choice that I can remember where they've said, like, what should your u be here? But like I said, it would be, here's an integral, here's the u substitution, what would the integral now look like given that? So you need to be able to, like, be able to convert these in terms and in terms.
We don't need u substitution, do we?
Sorry, you don't need u substitution for this? I mean, like, technically, you're using u substitution when you, like, if you mental math it kind of thing. So I mean, yes, it's still a u substitution, even though you could, you don't necessarily have to, like, use it.
Secant of u, tangent of u, which is going to give us
right.
secant, right?
Yeah. So let's rewrite this.
So it's like you would just have secant pi t, tangent pi t, or secant pi t.
Right. Yes, but you still have to account for it because well, we have, so it's going to end up being secant u, tangent u. Okay, secant u, tangent u. We don't have pi dt though, right? We just have dt. So I have to divide both sides by pi, so it's 1 over pi du equals dt. So I have dt here, and the 1 over pi goes out front.
Could you not just solve this from the original function though?
You could, but again, you'd have to make sure you include the 1 over pi, and I don't think some people would be able to do that if they weren't, careful.
So
So you could, if you wanted to, absolutely, yes. Okay, the u substitution is there to just help us keep track of things.
But no way to, like, really see that from the original function that you said.
Not easily, no, I would say. I mean, yeah, you can, but it wouldn't be easy to do. You definitely want to use u substitution here, I'd say. All right, what are our new limits of integration going to be? 1 over 6 becomes what? Well, plug it in for t. Pi over 6. 1 over 3, plug it in for t. Pi over 3. Okay, so now I'm going to get this work going here. So let's see, we got 3 times 1/3 squared minus 3 times 1/6 squared plus, and now at this one I can only integrate at this point, so it's 1 over pi, integral of secant u tangent u. Yeah, derivative of secant, the derivative of secant is secant tangent, so the integral of secant tangent would be secant, so it's secant u. And we're going to evaluate that from pi over 6 to pi over 3. Okay. I'm going to simplify this sum here. So it's 1/9 So that's, then times 3, so it'll be 1/3 minus. 1/6 squared is 1/36. 3/36 is 1/12. Okay. Plus, and that's 1 over pi secant of pi over 3 minus 1 over pi secant of pi over 6. Okay? At this point, if it were a free response question, you're done. Right? You don't have to evaluate trigonometry in a free response question. So that's your answer. Circle it. You're done. You didn't actually even need to simplify these here. You could have just brought these down, the 3 1/3 squared and the 3 1/6 squared, and then add it together with these. Okay? But once you evaluate like that, I mean, you're done. You don't have to evaluate things. Well, let's go ahead and evaluate them, right? So let's see, I'm going to convert this to 4/12 minus 1/12 there. And then let's see, secant of pi over 3, bless you. So secant is a reciprocal of cosine, bless you. Cosine of pi over 3 is 1/2, so the reciprocal of that would be 2. So this is plus 2 over pi minus. Secant of pi over 6 is, that's 1 over cosine of pi over 6. Cosine of pi over 6 is root 3 over 2, so it's 2 over root 3. Like so. And I'm not going to bother simplifying. I mean, I'll do 3/12, so 1/4 plus 2 over pi minus 2 over pi root 3, and I feel like I'm good with that. We don't need to go any further than that. That's just too much otherwise. Okay. So there it is. Question, Connor?
How can we change the integral of pi over 3 and pi over 6?
Because 1/6 and 1/3, those were our limits of integration for what variable? T. We changed our limits of integration in terms, we changed our limits of integration in terms of u. Those variables then, the values need to change. How do we change it? Using our u substitution. The same thing here. 1/6 plugged in for the t times pi becomes pi over 6, so u is pi over 6. 1/3 plugged in for the t, pi over 3, so u is pi over 3. Okay, just reconvert it, translate them. All right, last one I'm going to have you guys try. Yeah.
Just for like, I guess, because you did separate them, did you need parentheses when it was 1/3 minus 1/12, like in parentheses, plus 1 over 5, so all the rest of the parentheses?
Like you said, I should have grouped these together.
Yeah, I think it's did that.
This I don't think it matters so much because it's addition here, and yeah, that shouldn't it's equivalent without the parentheses to
I guess
with
it's
parentheses.
on the bottom one, right?
Like down right here.
Yeah.
So like again, you're saying here and here.
Like just to show that they were together.
You can, but it's not necessary. I would say it's not necessary. If it helps, like to keep your thoughts organized, though, by all means do it. Okay, but you don't have to. All right, let me have you all try this one here. Integrate from 0 to the square root of pi x times the sine of x squared plus pi dx. Okay? There she blows.
Is it the square root of pi?
Yep. 0 to the square root of pi.
These are great.
I think this one's not that bad.
Yeah.
I mean-
Problems in general.
Oh, okay.
I'm going to let you equal x plus pi.
Yes.
Alright.
Wait.
Would this be like a calculator problem? Like, or would you have to like take the square root of pi by itself?
Sorry.
I guess.
You'll see what happens. Just wait and see what happens.
Could there ever be like a situation, I guess, where they want you to use the other way over this way, but like purposely making your upper limit something that would require a calculator?
I think either way you do it wouldn't require a calculator here. It shouldn't end up having to require a calculator. You'll see. You'll see. Give it a shot. You'll see.
Yeah, I just thought.
I don't work
Now you
out
see it?
really-
Okay.
I don't work out really nicely because you have a root of pi, 0. So it won't matter. We have to show plugging in the limits, or does it not matter?
Like you just like skip straight down to what the answer is?
No, instead of like showing me plugging in like.
Oh, converting the limits?
Cosine of root pi squared plus x. I show like what I get for each.
Yeah, I think that should be okay, yeah. That should be fine, yeah.
What? I didn't do it that one.
But yes, it should be, if you convert them in terms of u, yes.
2 pi.
What happened? Well, the right thing is taking a bigger bag of checkers, by the way. Angle side. Yeah, it's negative cosine.
What'd you get? I got 1. You got 1 for these?
At some point.
That's fine. We're ready to pull that 1/2 out front. I know.
Sudoku. Brian, we're doing these at school. We're just in my house. Better for myself.
This is the thread asking me, I got fucked up, say, kudos to the deep web or
Chill.
guys did this.
I should have looked at these schools.
I could get, I'll put it for you. Is your volume all the way down?
I just read,
Make sure your volume.
the integral of sine is negative cosine. Okay.
Because the derivative of cosine is negative sine.
See, I don't, I just have to like guess, right? Did you like put on the board like?
It's a matter, if you know your derivatives, then you know your integrals.
When we started, like when we did.
I know exactly what it is.
Like
You don't
fully concrete limit before we got into
Nope.
integral. So it's kind of like, I know.
Now
that
you get to-
It goes from sine to
Yeah,
cosine.
you wanna know.
So yeah, so I mean,
That's the phrase,
this,
yeah.
I mean, and again, I'm not saying my way is the right way, but when I still, to this day, this is the same way I learned it back when I was in high school, learning this calculus stuff. In my mind, when I see something like, when I want to integrate sine, I think to myself, the derivative of sine is cosine. So integrating sine, you know, I need to think, okay, if the derivative of sine is cosine, and the integral of cosine is sine. I'm not integrating cosine, I'm integrating sine, so I have to go to a different one, okay? Derivative of cosine is negative sine. If I'm integrating sine, then it's going to integrate back to a negative cosine. So you just have to know your
So you're
derivative.
taking the derivative, it's sine to cosine.
I mean, you still got the right answer, it doesn't matter.
Correct.
In the end, it won't matter, but. Yeah, watch that video. It is.
Derivative of sine,
Your brother's not even anything interesting.
cosine. Derivative of cosine, negative sine. So, if you are integrating positive sine, then that means that needs to be negative. I mean, again, the idea is like, whatever your answer is, you should be able to take the derivative, like, so, when you're integrating something, you integrate this thing. You should be able to take its, when your answer, you should be able to take its derivative and get back to this, okay? So if you're like integrating cosine, and you just say, oh, that's equal to sine. The derivative of sine is negative cosine. Does not match up to positive cosine. See what I'm saying? So like, you can always check it backwards too. Take that derivative and see, would that result back to my integrand? So so 2 pi is the same position as 0. So what's cosine of 0? 1. So it's negative 1. So it's negative 1/2.
So wait, can you simplify the problem? Like, I'm putting on something and then I don't know.
Like evaluate sine and cosine, you mean?
Yeah.
Yeah, you should be able to. Because if you square, that's the square root of pi. Oh, I see what you're saying. 2 pi, yeah. So yeah, oh wait.
okay, you kind of did two things at once here, and you kind of like, doubly accounted for your use of substitution. So either you change your limits of integration, and then you use limits in here. So it'd be -2 cosine 2 pi minus -2 cosine pi. So you should have plugged it into this. So not substitute back in for the u and then plug it in.
No.
So if you convert, you plug it in as soon as you integrate.
Are you sure
you
you're not
plug it back
negative
into the u. If you don't convert,
Ryan got
if
one.
you like,
I also
you
got
get back in terms of x,
negative one.
then you plug these in for the x and the x. Okay.
So it's just gonna be -2.
You don't have
Should be
x in
cosine.
front.
No, but that's
yeah.
not.
Yeah, I don't. I guess we'll see.
Okay, so let's see here. So we're going to let u equal what?
I'm pretty sure man.
X squared plus pi. du is equal to 2x dx. We don't have 2x dx, we just have x dx. So we're going to divide the two over, make it 1/2 du equals x dx. So this results in then 1/2 the integral. Oh, I'm like way zoomed in. Let me zoom out more. Okay, there we go. 1/2 the integral of sine of u du. I'm going to go ahead and convert my limits of integration. So 0, plug it in for x here. 0 squared is 0 plus pi, pi. Plug in root pi. Root pi squared is pi, plus pi is 2 pi. So u is 2 pi. Okay. Integrating sine, we get negative cosine. And we're going to evaluate that from pi to 2 pi. Cosine of 2 pi minus cosine of pi. Cosine of 2 pi is 1. Cosine of pi, -1. So plus positive, so it's 1 plus 1, 2. So -1 is your final answer. Bless you.
Wait, what was why the negative one?
When you integrate, so we got a positive 1/2 when we first did the use substitution.
Oh, I just did. I'm so stupid. I wrote -1/2 minus 1/2.
Okay? Integrating sine becomes negative cosine. So a positive 1/2 becomes -1/2 cosine u.
Oh, okay.
Integral sine is negative cosine, so -1/2 cosine u.
Okay.
You got it okay? All right. Question? Okay, so I mean again, check through your work. Let me type it on my calculator here. So let's type in our calculator and just see. I mean maybe I made a mistake. Let's see. So I'll change my mode back to the pretty type. Hey, it's math print. Okay. Math 7. Oh no, math 9. There it goes. Okay. So from 0 to the square root of pi, x sine of x squared plus pi dx -1. Okay, so I can take a look at it there, Tyler, if you'd like to see. That's what it should be.